Welcome. We now start chapter 10 titled Correlation and Regression. And in this chapter, what we'll be doing is looking at a possible relationship between two quantitative variables. So this is called bivariate data, two variables, in the interest of determining if a linear relationship exists between them. And we will dive in here with an example to first learn this graph called a scatter plot. So a psychologist developed a scale called the General Anxiety Scale, we'll just say GAS there, to measure the general anxiety of an individual. The GAS score is on a scale of 0 to 10, with higher GAS scores corresponding to more anxiety. The bivariate data below gives the GAS score and the hours of sleep last night for 15 adults participating in a study on sleep and anxiety. So our independent variable, also called the explanatory variable X, so this is the participant's GAS score. So we're wondering if that can help explain the hours of sleep they get. So that's going to be our Y variable or dependent response variable in our bivariate example. So we're wondering if GAS score anxiety is related to hours of sleep. All right, so a scatter plot is a graph of the ordered pairs for our participants. So let me key in here on, so each of these values is each of these ordered pairs that is graphed is a participant. I'm going to focus on this participant, which is my fourth one there. So there was a participant in the study whose GAS score X was 5.1, and the hours of sleep they got last night was 6.0. So the scatter plot, that participant, we'll just label it there. So if we come down here, their GAS score was 5.1, and their Y value was 6.0. So every one of those points has an X value and a Y value for each of our participants. All right, so I'm going to say here that each of these XY ordered pairs is what we actually observed in our data. All right, so first step is to create a graph called the scatter plot. And I've done this on the calculator already. So the scatter plot is the graph of the ordered pairs. You do not have to graph this right now. I'll put a link to how to graph a scatter plot in the description below. But for now, we're just getting a feel for this chapter. So we have some data. We're wondering if there's a relationship between the variables. We graph that data and then decide if we think there is a linear trend, sort of a straight line trend. So it's not looking perfect, but there does seem to be a downward pattern here, whereas GAS scores going up, hours of sleep tend to be going down. So in order to determine if we have enough evidence to support the claim of a linear pattern, we conduct a hypothesis test. So we can conduct a hypothesis test to determine if we have enough evidence to support a claim of a linear correlation between GAS score and hours of sleep. So I'm not going to run that hypothesis test right now. We're going to move forward and say if our evidence does support that claim, then the next step is to find a straight line that best fits that data, and we can then use that line to make predictions. So this line you see, it has different names. It's called the line of best fit. More officially here, it's called the least squares regression line. And then sometimes I just say for short there, regression line, but it's our attempt to describe the relationship between the variables. Now, that line here I've provided, but let me talk about notation. So X and Y represent what we observed for our participants. But I'm going to be using this straight line to make some predictions in general for a person, say, that has a GAS score of 5.1. So on my line at 5.1, that Y value is different than this one. So this Y value is 6, but on the line, we'd like to know the Y value for that point on the line. So what happens here for that X value, I can't use the variable Y again, because Y is already in play. Y represents what we observed for each of those participants. So all we do is switch to a different symbol. So instead of Y, we're going to do a Y hat. All right, so that Y hat can be found using this regression line. So that value Y hat is a prediction, and let's go ahead and find that Y hat for this particular value of X. So let's use this regression line to find the predicted hours of nightly sleep for a person whose GAS score is 5.1. All right, so they're giving us X, 5.1. And later we'll learn how to find this regression line, but it's given to us now. So 8.53 minus 0.30x. And then all I'm going to do is substitute my value of x. So 8.53 minus 0.30 times x. I'll put a times there. So 0.30 times x. All right, so we'll type that in, 8.53 minus 0.30 times 5.1. And that is 7. So I'm going to put units here to remind you what we're doing here, 7 hours of sleep. So I predict that for people with a GAS score of 5.1, hours of sleep is 7. So the idea here is that it's a prediction, and it kind of represents on average. So for everybody that has a GAS score of 5.1, on average, I say they get about 7 hours of sleep. So 5.1, I'm predicting Y hat. So this is the prediction. All right, so there can be certainly other factors that come into play when it comes to how much sleep you get other than anxiety. So this particular participant, they actually only got 6 hours of sleep, where we just decided here that on average, I would predict people to get 7 hours of sleep. So there's going to be other variables that affect sleep other than anxiety. So there's going to be variation in the data that is not described by the GAS score, but other factors. So for example, health or diet or habits before bedtime could all affect sleep as well. So we recognize that there are other sources of variation in sleep, but here it's our best effort based on these 15 participants to try to understand a trend based on anxiety. All right, so this is our goal here in chapter 10, to have data. We draw a scatter plot to see if we see what appears to be a trend, and then we can take a next step and conduct a hypothesis test to determine if we do have enough evidence to support that claim. And if we do, we find this line that describes the relationship. So in this course, we're going to be looking for linear relationships only. We won't be studying nonlinear, like a curved relationship. We're going to be looking for straight line patterns. The direction of the correlation, the relationship, will either be positive or negative. So we've just looked at a negative relationship case. As X increased, Y decreased, and then we could also have a positive relationship possible where X increases and Y increases with it. And of course, it's also possible that you're studying two variables and they have no relationship at all. So we would have no correlation. So direction, positive or negative, form, we're going to be studying linear. And the strength of a relationship we'll learn how to measure as well. But strength in general just means that we have a strong relationship if our data here is tightly fitting a straight line pattern. And we will investigate that further as well as we go through chapter 10.